Hey, what's up, guys? This is Sean here again. So this time let's take a look at today's daily challenge problem number 394, decode string. It's a very classic stack or recursion problem. Okay, so you're given like an encoded string here and return its decoded string. So encoded strings like this. So you have a number of the encoded strings here, like a k and then encoded string here, where the encoded string inside the square bracket is being repeated exactly k times. And note that k is guaranteed to be a positive integer. And you may assume that the input string is always valid and no extra white space, and square brackets are well formed. And whenever there's like a integers and numbers, there will always be it will always follow like a square bracket. And then inside the square bracket, there will always be a string, right? So there won't be a 3a or this one here. Okay, cool. So then we have some examples here, right? So for the first one, as you guys can see, we have 3a's. So a is being repeated 3 times. That's why we have 3a's. And then we have a bc. bc is being repeated 2 times. That's why we have 2bc's here. And then example 2 is like a more complicated scenario, which we have a nested square bracket. That's why we have C repeated 2 times, right? And then we have 2C, and then we have a becomes 3ACC, right? And then the ACC will also be repeated 3 times. That's why we have ACC, ACC, and ACC. All right, and that's the description of this problem. You know, actually, this problem is very similar like the other problems. I think it's called number of atoms. You know, the only difference is that for that problem, the multiplier, I call this one multiplier, is on the right side. It's at the end on the right side of the bracket. But for this problem, we have the multiplier first and then followed by the value that's we need to repeat. And for this kind of problem, there are usually like two solutions. I mean, you can either use recursion, right, or you can use a stack. I mean, for the recursion, I think every time when you see like a left bracket, right, and then you just go inside a recursion, and and then you pass in whatever inside this bracket into the recursion, and then you just return a string, and then you just continue doing that. I mean, I think recursion will definitely work, but recursion is kind of slow. So today I'll just show you guys the stack solution, which is the faster one. So for the stack solutions, it's similar for this kind of problem, even for the calculator, right? I mean, they're all having the same similar structure, similar idea here. So the idea is that every time when we see like a left bracket, we'll just push like a new a new a new item inside this stack here. So so for this problem, the item I'm going to push into the stack have have two parts. So the first one is the multiplier. You can call it multiplier, right? And then the second one is a string. It's a string that will be repeated by this multiplier. So, and every time, right? So when we see this, when we see a left bracket, I will just push. So, and since when we see this left bracket, we already know the numbers that for this multiplier. That's why I'm going to push it. And for the string here, I'm going to push the string with like empty string first. And then whenever we see like a right bracket, I will pop these two things out. So which means that, I'll show you here. So at the beginning, I will have like, I'll have one and the empty string here. Okay, an empty string. So I'll just use this one as an example here, right? So example 2 here. Now we have 3 here, right? So it's 3, and then we seize another left bracket. That's why we have this 3, and then we have like we have an empty string here, right? And then we have a here, and then we will have like basically we will have a in here, okay? And then we seize another a 2 here, right? We have another 2 here, and then we seize another like left bracket, and then we'll add another layer of these things here. So I'll add another 2 here, and then of course it's like another at the beginning it's an empty string here, right? And then we have C here. So every time when we see a letter, right, we always append this letter to the top element, to the top elements here. That's why we always append this string onto the top element of this second element here, right? Because the first element is always the count or the multiplier, and the second element is a string corresponding to this repeating number, right? And that's how we construct the stack here. And now we see the first closing brackets, right? Every time we see a closing bracket, we pop these things out. So we pop it out, and we'll have two values here, right? So the first one is a multiplier, second one is a string that will be repeated by this number here. And then we have like what? So we have a C and C, right? So C repeated twice will become C and C. And then we'll just append this CC to the same thing, right? So this thing is gone. So I will append this CC to the top item, to the top item's second element. So now this thing will become to ACC, right? And then we have another ending brackets. So we do the same thing, right? We do the same thing here. So now we have this 3. We have this because here we have a 2C times C. So now we have a 3 times ACC. That's why we have a 1. Now we have a ACC, ACC, and ACC updated to here. And in the end, I can simply return the values, right? The second values of the only items left in this stack. And that's going to be our algorithm. And you can use this one to apply to all the other, like either the calculators or anything that has like this bracket, either a curly bracket or square brackets, doesn't really matter. All right, cool. So that's pretty much the whole idea here. And let's try to implement this code. All right. So like I said, we have a stack equals to, I'm going to append this one and an empty string here, right? So actually this one doesn't really matter because all we need is in the end is just this empty string here, right? It's just the second element here, okay? And then we have a n equals to the length of s, right? And then we have what? We have I equals to 0. And we have a while loop, right? So while I is smaller than n, then we continue doing it. So, and then in the end, like I said, we simply return the stack, right? Stack the only element left in the stack, and then we return the second one because the first one is always the multiplier, right? And the second one is the string we will be needing for our answer here. So the first scenario is that we seize an integer, right? So when we seize an integer, because the integer could have like multiple digits, that's why I'm going to use a while loop to find the integers. Find uh, multiplier. Okay, so basically while the si is digit, so I just check if this one is digit, I just use and I'm going to use a current count, right? Current count equals to 0. That's how I maintain the count, right? And then current count equals to current count times 10, right? Plus the int of the si, right? And then I do I plus 1. That's how I calculate this current count. So that's that. And second one is this. If the si, right, is equal to what? To the left brackets, right? Then like what we said, every time when we see like a left bracket, we're gonna append another item, another layer of items here. So and now the first multiplier will be the current count, right? And then as always, we always initialize it with an empty string here, so that we can update this one later on. Okay, and then don't forget to reset this count back to 0, right? So that's that. Else if, right? So else if the si is equal to the ending brackets, right? So that's the ending brackets case. So for this one, we need to pop the top items out. And since we have two items in it, that's why we're gonna have like we have a multiplier, and then the second one is the string. I can call it string, right? Equals to stack dot pop. Popping this one item will give us two values, right? And then I'll just do a stack dot -1. So the -1 will give us the items on the top after popping the top one, right? And then we're gonna update the second one, the second element, which is the string, right? By concatenating the string times multiplier, right? And the last one, right? So the last one is just like just the letter. So for the letters, we simply just update the stack -1, which is the string, right? We plus that with si. Cool. Yeah, and that's it. So the reason I add this thing, I add the like initialize one with empty string is because when there's a case that we have used all like for example this one. So if we don't have like the a starting array here, this stack here, it will become empty, so it will throw an arrow. That's why I just initialize stack with an empty string here, so that it will not arrow out. Yeah, I believe that's pretty much it is. Okay, let's try to run the code, see what happens here. Oh, I know what happens. I forgot to increase the I here. That's why it will never finish. Okay. All right. So since we're using a while loop, right? So we do an increase. We increase I by 1. All right, cool. So accept it. Submit. Okay, so success. Yeah, I think that's pretty much it is, Okay, oh, how about time and space complexity? Right, so for this one, actually, of course, first layer of the time complexity is of course the n, right? So n times something like what? Like this is the part that will use some of our time. It's because we multiply the strings, right? Basically, this is like the concatenations. So I would say it's something like are in the range, all integers in the S are in the range of 1 to 300, right? So I think the biggest we have is 300, right? So it's going to be 300 and of what? Of the it also depending on the layer, the layer of the 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 nested the layer of the nested brackets, right? So for example, if we have 300, right, and then we have A, B, C, and then we have another 300, right, and then C, and then something like this, and another 300 of BD, right? And then we have a three ending bracket, so we can gonna have like 300 times this and 300 times that. So so it's gonna be 300 times 300 times 300, right? Something like that. So the number of this thing, the number of the 300 will depending on the uh, nested squares, right? But anyway, that's the rough estimation of the time complexity, right? And space complexity is just it's a layer of the stack, and plus the layer of the stack plus the string here, right? The total number, the total length of the string here. Yeah, I think that's pretty much it is. Just I think this is a very useful technique. There is like a bunch of other problems which are similar as this one. So you can call this kind of serious problem. I recommend you guys to practice this kind of serious problem to to understand how can we use this stack, right? To keep track of each layer's values, and then how once this current layer is finished, how can we calculate the value of the current layer, and then how can we append the current layer to the previous layer so that we can I mean uh, go all the way back to the first layer, which is going to be our answer. Okay, cool. I think I would stop here, and thank you so much for you guys to watch this video. Stay tuned, and I'll be seeing you guys soon. Bye bye.